My name is Ryan Coleman, Vice President of Engineering for Environmental Operating Solutions, Inc., or EOSi. EOSi is based in Massachusetts on Cape Cod, and we provide non-hazardous and environmentally sustainable chemical solutions coupled with advanced automation and technical services to support biological nutrient removal applications in wastewater treatment systems. We offer exceptional product quality, technical support, and innovative automation techniques to enhance the efficiency and performance of municipal and industrial wastewater treatment facilities of all sizes.
I'm Randall Pulsifer, Automation Manager at EOSi in Pocasset, Massachusetts. Previously, we had offered a PLC-based control package called NiTrack to optimize microseed dosing. It costed over $160,000. We were challenged to reduce costs and create a cloud-based version of the control system. Familiar with the unique flexibility of ignition, we developed a virtual NiTrack on an Azure cloud-based ignition platform utilizing the Cirrus MQTT ignition modules and cellular I/O gateways to post field data directly into ignition tags. The development of the virtual NiTrack took 6 months, launching on January 1, 2020. This lucky timing allowed us to commission 9 systems remotely during the depths of the pandemic. Now, creating a new NiTrack controller is as simple as instantiating a copy of the virtual NiTrack UDT and configuring it. Most importantly, ignition has allowed us to reduce the control system cost to as little as $800 in some cases and eliminate the costs of on-site commissioning. In essence, we've revolutionized our control system offering, reduced our costs dramatically, and improved the customer experience, all while never leaving Cape Cod.
I'm Dave Fournier, Automation Engineer at EOSi. Let's explore the infrastructure that supports a cloud-based control system. It starts with a Windows server installed on an Azure virtual machine, which hosts Inductive Automation's Ignition platform. Inside the Ignition platform, which includes a full-blown historian utilizing an Azure SQL Server, Cirrus MQTT engine, as well as Twilio's alarm notification module. In the field, cellular transmitters and IoT gateways with Ignition Edge are used to pull and push data where appropriate. Through the magic of MQTT, live process values appear in the Ignition tag browser for use in our control algorithms. Using Ignition's user-defined types, we were able to incorporate our proprietary logic and calculations using a configuration of expression and memory tags, including tag event scripts. Once the logic is in place, the algorithm results are then sent back down via MQTT to the IIoT gateway to directly control analog outputs to the chemical dosing pumps. What was a concern at the beginning of developing a virtual controller rather than a traditional PLC was the reliability of using the cloud for real-time control. To that end, we developed watchdog elements at each interface to be monitored at the server level. The virtual machine hosting the Ignition platform is monitored by Uptime.com, a third-party service. The remaining interfaces, such as communication with the site PLCs, IIoT gateways and cellular transmitters, and the SQL database are all monitored using Twilio to notify personnel in the event of a failure. With the infrastructure complete, security was added using Ignition's identity providers and security zones, ensuring users must have the correct role prior to having application access and control. Each EOSi prospective application for supplemental carbon dosing in the wastewater treatment process follows the same standard layout designed by the automation team. Once the application loads, the user is greeted by a dashboard showing the virtual NiTrack's most critical categories, including control system overview, which displays each interface's status, process values available in 3 formats: real-time, daily average, and weekly average, quick trends to view parameter history in a daily, weekly, or monthly format, tank inventory and consumption data, which includes a user-configurable low inventory alarm, pump overview, which displays pump status and allows the user the ability to start and stop dosing. On the dashboard and throughout the application, when performance upsets or failures occur, the interface will highlight the issue by indicating red or yellow if the status is unknown. By using the navigation menu, which transforms to show additional views, we can navigate to the anoxic basin. The anoxic basin screen shows parameters as a process overview, highlighting the inputs and outputs of the control system, as well as the set points used in optimizing the feed for chemical dosing pumps. Each parameter can be individually trended by clicking on the component for a quick historical analysis. The moving analog indicator was also configured based on a rolling 7-day history to identify parameters outside of the norm. The detailed pump views provide operators full control over the pumps along with status indications, detailed alarms, and counters to help assist with preventative maintenance. In the alternate modes tab, operators have the ability to place the pump in manual during sensor maintenance. Or, if multiple trains exist, the maintenance dose mode can be used to mimic a healthy train's dosing rate. Pump properties allow operators to control and set minimum and maximum speed rates. EOSi pump skids, which are built in-house, contain a calibration column to fine-tune the pump. When a calibration is started, the pump will run for 60 seconds at 100% speed, and the new pump capacity value can be recorded. Historical data comes in two forms to analyze performance. Using Ignition's built-in power chart, we were able to create unique views along with the ability to quick toggle parameter categories. In addition, we set up multiple axes within each chart to group together data with the same units and range. A data export button has been added to give users more control over the data they export. First, set the chart to the desired date range, specify the interval between timestamps, and finally click the data export button. This action triggers an on-click event that runs a script using Ignition's built-in system functions to query the dataset and export the contents into an Excel spreadsheet. We also integrated the Kybus Lab Apex Charts module to create an interactive environment, enabling users to transform data into unique visual formats. The Field Equipment view tracks the health and performance of deployed wireless transmitters. The user can then toggle between the engineering unit or the raw 4 to 20 milliamp signal. We also put together an Assets on Site view, which uses an API script to pull information from our asset management database, which includes field and factory maintenance dates, as well as tracking information. If an alarm exists and is active, it is indicated by the navigation menu. The icon will pulse red to draw the user's attention to the issue, which they can then open the alarms page for a more detailed view. In addition, behind the scenes, alarm pipelines will also notify plant personnel via text or email. The last view is the Equations tab, which houses our control algorithms, displaying both calculations and real-time values. This enables EOSi engineers to view and adjust the algorithms as needed. The framework of the prospective application was chosen for its unique ability to be easily accessed from devices with varying screen resolutions. By using a combination of breakpoint, flex, and coordinate containers, we configured each perspective view for use in the field using a phone or a tablet, or for use at a dedicated workstation. For EOSi, the Ignition platform has been life-changing in our day-to-day business. We've transitioned away from a traditional PLC cabinet to a compact enclosure containing an IIoT gateway running Ignition Edge and a power supply. This cost reduction has enabled us to offer our cloud-based control system at no additional charge, provided customers are purchasing our Micro-C products. Ignition's capabilities and functionality have allowed EOSi to seamlessly integrate our cloud-based control system for the past 4 years. This integration empowers our customers and engineers to easily access applications, to control processes, and quickly diagnose issues. In 2024, leveraging Ignition, EOSi expanded our solutions to include a cloud-based control pump skid capable of deployment anywhere. The user experience with Ignition has garnered consistent positive feedback from our customers and engineers. For our automation team, Ignition has presented endless opportunities, making it an invaluable asset to our operations.